So I'm going to do another short video on how to simulate things that are popular on YouTube. And one of the things you'll find are called LED chaser circuits. So just do a search on YouTube and you'll get all kinds of them. This one's showing you how to do it with a 4017. This one has a couple circuits with a 4017 and a 4015. And so the first thing you're going to want to do is get models for the 4017 because it's a little bit difficult to build discretely out of the LTSpice digital library. So I found this Sparkpunk on GitHub, and he has a library and some components and some example circuits you can use. You can just select these and copy them to symbol and library and circuit schematic files of these names, and it takes a little bit of time, but you can do it, and you end up with something that looks a little bit like this. So I put everything in a Windows 11 wants to start a backup all the time. I guess that's fine if you want to count on Microsoft to do your backups. But anyway, I got off track there. The SPICE files for the schematics and the library file, and then symbols. The two symbols that he had there, the 4013 and 4017. Using the 4013, you could pretty easily create a 4015. It's just a shift register. So if you, did I look up the data sheet for that? Let's see, it's pretty easy to find. If you just, that's funny, I don't have, so if you just put in a CD 4015 data sheet, and oh, there was an image of one right there, but you can see it's really just a bunch of flip-flops, D flip-flops in a shift register. So you can build that pretty easily using the 4013, and you'll have your 4015 circuit if you want to use a CD 4015. So before I, let's see, LTSpice. So let me slide that over. There is a new version of LTSpice. It's not bad. It has a, I guess it has an enhancement on AC simulations or something, and graphically it's a little bit different. So just takes a little getting used to something different. But basically, you take one of the any of these and just open them up, and if you run this simulation, if you do current, you'll just see, oops, and they'll just run down the line, and then it'll start over and run down the line, just like they show in the videos. That's how it'll work. And you can play around with component values, different, different kinds of circuits. If you really want to get into it, if you can't find a model for your specific LED, takes a little tweaking, but you can make from a discrete LED a diode symbol. I don't see, there we go. So if you take an LTSpice, just take their generic diode. You'll have to look it up. It could be a whole video showing you how to make this generic diode have characteristics of a real LED or a real diode. But you can usually get pretty close if you wanted to. Come up with your own. If you can't find a model for the device you want, the diode you want, you can make your own that works pretty close to what the real life part would do. So that's really, you can build these circuits. Let's not say that, but all of these, I guess I should have said, one of the things, so by putting them all in that one folder, the library, the symbols, and the schematics, and then you add this include. If it's all in the same directory, you just can do this include statement so it knows what the library name is, and then that'll just work just fine. It'll know where to find the models if you do this, and since everything's in that one directory, it's portable. Whoever you give this to, I think if you do it this way, it would just work. One other type of chaser circuit that you really want to maybe do some simulations on, if you do one that uses transistors instead of digital circuits. Here's a couple, 3 different ones that I've put together. So I don't know if it's still there, but I found this one on YouTube and I simulated that. But the other ones, I just played around with what can you do if you wanted to get more LEDs. Let's see. Oh, I did find this one on YouTube. Let me zoom in. So if you type that into YouTube, maybe you'll find that one. And that's not the same as this, is it? Oh, looks like maybe it is. Yeah. And then I did a third one. I'm not sure why I did a third one. Playing around with that a little bit. Oh, I guess it's self-starting. What happens if I simulate that one? I don't remember. So if you just look at the current through the LEDs, you see it kind of acts weird, but you can kind of see it would step through them. So that is really all I wanted to do, was give I was hoping it would be a shorter video than this, but a pretty quick video on how you could simulate these LED chaser circuits. This Knight Rider one, they go back and forth. These other ones, it goes around in a circle. Looks like this guy had his do 2 groups that chase each other around in a circle. This guy has a couple different ones. Anyway, you can do a search on that. Then one more thing, I guess, before I end this, is the guy who wrote LTSpice, Michael Engelhardt. He's at a new company now, Corvo, and he wrote for them an even more powerful simulation tool called QSpice. Um, it does a lot of things very few Spice programs can do, um, especially in that it takes in programming languages, hardware programming languages. Um, I believe it takes Verilog and VHDL. So you not only have a really powerful analog simulator, you have a really powerful digital simulator. And I think it's free. I'm not sure. But if you really want to get into it and you are willing to spend some time learning a new tool, you should take a look at that one. Anyway, I think that's about all I have that's worth talking about. Till next time, bye.